Okay, let's get started. Hello, and welcome to the first session of the webinar series, Rethink How We Build. My name is Sonia, and I'm happy to moderate this exciting session today, jointly with my colleague, Julia. Hi, Julia. Our topic for today is how we can move towards a resource-efficient and carbon-neutral built environment globally. We have invited international experts to discuss this topic from different angles over the course of 3 webinars. This webinar series is organized by the Implementing Office of the National Designated Entity Germany, and the NDE Germany is one of 161 focal points that have been created in the framework of the technology mechanism of the United Nations Framework Convention on Climate Change. Our aim is to facilitate the introduction, use, and transfer of climate-related technologies worldwide. And the NDE Germany is hosted by the Federal Ministry for Economic Affairs and Energy, BMWI, on whose behalf the webinars are being organized. So before we start with our panelists, let me give you a bit of context for our webinars. The building sector, as a lot of you know, is undergoing a significant transformation globally. So over half of the buildings that will stand in 2060 have not been built yet. Especially in Africa and Asia, the number of new buildings will increase rapidly in the coming years. This fast growth presents a challenge to meet the goals of the Paris Agreement. Hence, what we build today already has severe consequences for our future emissions. And this forces the buildings and construction sector to rethink building materials and practices. One important aspect in this discussion is embodied carbon, meaning the footprint of a material in the built environment. It considers how many greenhouse gas emissions are released through the entire supply chain. Currently, around 104 nationally determined contributions, NDCs, mention specific climate actions in the building sector. However, only a very small number of NDCs address construction and embodied carbon linked with the manufacturing of materials such as cement. So during the next 3 weeks, we are asking our panelists to discuss what embodied carbon is, how it can be integrated into NDCs, what measures are available for substituting raw materials, how cement and steel can become zero carbon, and what examples of low carbon actions in the construction sector exist globally. Today's session introduces the topic embodied carbon. It explains the concept of embodied carbon, its importance, how it can be measured, and how it can be integrated into NDCs. The webinar also discusses the successful case of public procurement standards for buildings in Finland. Throughout the webinar, we want to encourage an open discussion. If we can have the next slide, please. Our speakers will first provide some inputs, which is followed by a panel discussion. All listeners are muted, but you can type your questions in the Q&A box, which you can see at the bottom of your screen. And you can ask questions either for one presentation specifically, so we will pause after each presentation to allow for a few questions, or during the panel discussion. And my colleague Julia, she will make sure that your questions will be integrated into the webinar. And of course, you may also tweet about today's event using our Twitter handle. The meeting will be recorded and uploaded to the homepage of the NDE, and we will also upload the speakers' presentations here. So in discussion today are Dr. Peter Graham from the Global Buildings Performance Network, Dr. Dirk Schwede from the University of Stuttgart, Marina Fecke from Wuppertal Institute, and Ari Ilomäki from the Ministry of the Environment. We are very happy to start today's discussion with some welcoming remarks from Mr. Malte Bornkamm. He's the head of the division Emissions Trading, Climate Change and International Environmental Policy at the Federal Ministry for Economic Affairs and Energy. Here we go. The floor is yours.
Yes, hello. Also, warm welcome from my side to all to the audience, and thanks to the NDE for organizing this event, this series of events. We're having this discussion today. My video hasn't started yet. Yes, I can see. We're having this discussion today in front of the new paradigm of climate neutrality, and there are more and more commitments on the international level in this regard. Currently, we're trying to get off the COVID crisis, and of course, the crisis had a significant impact on the short-term emissions. But of course, the long-term challenge remains reducing carbon dioxide emissions worldwide. And this makes government action more critical than before to put us on the right track to reach the global goals of the climate Paris Agreement. In 2020, the EU, Japan, South Korea, and South Africa announced net zero greenhouse gas emissions goals by 2050. Even China is reaching for 2060, and with the Biden administration, the US will rejoin the Paris Climate Agreement and is now also focused on achieving net zero. The long-term target of climate neutrality has direct implications for our midterm climate targets and short-term industrial policies. In December 2020, the EU submitted an updated NDC reflecting a climate target of at least 55% reductions by 2030 compared to 1990. And Germany committed in the spring to 65%. However, meeting these targets requires an unprecedented climate ambition in all sectors for transition to zero greenhouse gas emissions in Germany, the EU, and globally. And the building sector, of course, has a very central role. It's accounted for 16% of Germany's GHG emissions, or 118 million tons of CO2 equivalent in 2020. Germany takes serious steps for achieving net zero emissions in the building sector. But these emissions only account for the direct emissions of buildings, so which have are rooted by the energy use in buildings. The total carbon footprint of buildings is 38% of global total energy-related GHG emissions. 3/4 of these emissions are related to the energy use in buildings, but 1/4 is contributed to embedded emissions, embedded in the materials being used for the construction of the buildings. And these are contributed to the industry sector because these materials are being produced in the industry sector, like cement and steel, which is the focus of my department in the Industrial Policy Department. And the particular focus of the webinar series will be on these embodied carbon in buildings. And with this webinar, the NDE Germany contributes to sharing experiences from Germany, the EU, and globally on the technologies towards zero emissions in the building sector. And specifically, the following questions shall be highlighted. Which materials contribute most to embodied carbon in buildings? How can we shift to green or zero emission products for building materials such as cement and steel, which currently have a significant carbon footprint? Which role can governments and the private sector play in the decarbonization of the building sector? And how can they contribute to a zero carbon pathway? How can circular economy concepts be best utilized, for example, through reuse of building materials? What are the key technologies, product and materials which will be required in the future? And how can NDEs, the CTCN and the technology mechanism specifically support countries and private sector stakeholders? So we are looking forward to an insightful discussion with the international experts who agreed to speak at our event, and with the international audience joining us today and throughout the next weeks. So again, thanks a lot for all the speakers which are ready to speak and for the NDE for organizing these series of events. Thank you.
Thank you very much for those welcoming remarks. And now let me introduce our first panelists. This is Dr. Peter Graham. He's the Executive Director of the Global Buildings and Performance Network. abbreviated as the GBPN, which is a globally organized and regionally focused organization whose mission is to provide policy expertise and technical assistance to advance building energy performance and realize sustainable built environments for all. Peter, the floor is yours.
Thank you, Sonia, and thanks, Malte, for the opening remarks. I am going to provide a bit of an overview to begin with, and really to pick up where Malte left off. So Malte mentioned that we're talking about buildings, decarbonising the building sector in the context of climate neutrality. I think the most important thing that we see when we track the progress the building sector is making towards decarbonisation is that, in fact, emissions from the building sector are increasing. And 2019 was the year where the building sector had its highest ever recorded emissions. The sector is responsible for about 38% of emissions, and about a quarter of those emissions does come from the manufacture of construction materials, and principally cement and steel. What's important about this is that we need to address the rapid increase in new construction, particularly in Asia and Africa, and particularly in the housing sector, which is really where the majority of new construction is. There's a really strong opportunity to be able to address this embedded carbon issue as well through design innovation and material standards. And I'll talk about that in a second. Okay, let's see the next slide. Oops. Okay, so what are we want to take international action. We want to take national action, and obviously within the framework of the Paris Agreement and the UNFCCC, one place that we can begin is by looking at the NDCs themselves, National Determined Contributions. The GBPN assists governments to identify what kind of building sector actions are going to have the largest impact on their emission reduction and contribute most to achieving their national targets. And over many years, we've arrived at a pretty good formula for being able to address transformation in the market that leads to decarbonisation of buildings. We need to see the implementation step up. But essentially what we were looking for is this package of policies, including ambitious building codes, near zero energy building codes, rating and disclosure policies, which deal with the certification of the energy and emissions in use, finance, incentives, and labelling schemes, which provide market signals and improve access to finance for low carbon solutions. But really, to get that whole process moving, countries need to make zero emission targets, and the building sectors in those countries need to have zero emissions targets as well. We are not near that in the commitments that we see in the NDCs for buildings. When we think about zero emissions and decarbonising the building sector, we understand that energy efficiency in buildings is important, but we need an overall strategy that includes fuel switching and also decarbonising the power sector. So we need to see the building sector as an enabler of other reforms in different sectors as well, including in manufacturing and industry. We can draw on evidence and track record on how different kinds of policy measures do actually reduce the embedded emissions from the building sector. And we can link these up across the building life cycle to establish roadmaps and strategies for decarbonisation. So how do we incorporate these sorts of actions into an NDC? So there are really two approaches which can work in unison when we get to the point where a country wants to include building sector actions in an NDC. One way is what I call the top-down approach, and this is where an international organisation would begin working with, let's say, Ministry of Construction to establish a roadmap for decarbonising the building sector. And that includes perhaps not just building and construction, but also urban planning and enabling activities, including education and capacity building. The roadmap then is developed using a guide, which I'll explain in a minute. I was the author of this guide for the UN Global Alliance on Buildings and Construction on how to incorporate actions into NDCs. And then, of course, you can move into an implementation pathway, which is where the GBPN focuses its attention. There's another way of doing it too, which the GBPN is focusing on in Indonesia at the moment, and that is starting not at the national level, but really starting at the subnational level and working with the mandate of mayors and regional governments in a coalition to develop a plan for decarbonising a city or a local market, and then moving to that implementation stage. So the approach in both cases is really taking this three-step approach of mapping to identify the opportunities for emission reductions in a country or in a market, prioritizing based on emission reduction potential, finance and co-benefits and so on, and then implementing. But it's the central to all of this is good stakeholder partnerships. So this guide, which I wrote for Global Alliance on Buildings and Construction, is available online, and we're applying this guide actually to support Cambodia, and we used it to review Vietnam's NDC as well, building sector actions in their NDC. So in terms of mapping, we start with a process of identifying what is the building stock in a particular country, what's the level of new construction and so on, and then trying to identify where the emphasis should be for the sector actions. And in most cases, it's in the housing sector. So this is just an example of what we're doing in Indonesia there at the moment. When we move to prioritisation, we've mapped the building sector actions in NDCs, and we see that most of the priority is on policy reform, and particularly building codes. But there's also some commitments being made to develop rating and disclosure policies as well. Not so much on the embedded emissions, material standards and so on, although some countries like Senegal, for example, is looking at incorporating, they have incorporated local material, low emissions materials. Vietnam has looked at that too with non-fired bricks and so on. So there is some engagement there, but essentially we're looking at policy reform. But where the opportunities lie also is in understanding which sectors, which actors within a country have made the most ambitious commitments. And we find that cities in most places are making stronger commitments. And so the opportunity for countries is to align with their subnational entities to develop a national strategy that really draws on the most ambitious commitments from the building sector. It's also relevant that some countries are looking at aligning the building sector actions with achieving other sustainable development goals and also national adaptation plans, and trying to use building sector investments to drive economic recovery, particularly after COVID, and protect public health. So when it comes to implementation, which is the final step, again, we really think that the most important thing is to develop a long-term stakeholder engagement strategy, which enables the planning and implementation of building sector actions in NDCs in an iterative process, a continual improvement process. Without that stakeholder engagement and without a methodology for long-term engagement, it's difficult to see progress being made at the rate required to overcome increased emissions from new construction. Some countries like Cambodia have actually mapped out their implementation strategy in their NDC, which is pretty good practice. And another piece of work that we've been doing, looking at best practices for implementation in NDCs, has identified some key components of how to design an implementation pathway. And there are some good examples of development of political commitment, establishing a coordinating body, defining roadmaps, and also long-term stakeholder engagement from a number of countries. The example here is from Canada, which is just showing that sort of integrated approach from establishing the plan through to implementing it and engaging with their community on an ongoing basis. So there's some more support on the way. GBPN is working with PEEB and the Global Alliance for Buildings and Construction to launch a NDC Buildings Toolkit, which takes that guide and its 3 steps and is developing a framework of tools and other resources that countries can use to actually take those stages, the mapping, prioritizing and implementing further. And if you would like more information on any of this, please do not hesitate to contact me. There'll be some more information coming up, I think, later in the week at the roundtable, the Asian roundtable on buildings and construction coming up. It's being hosted in Japan. So please do contact me or the GBPN if you'd like more information on this area of work. Thanks very much, Sonia. Back to you.
Thank you, Peter. Your presentation was really helpful to draw the link between NDCs and the building sector and generally introducing us into the topic. Julia, do we have any questions to Peter's presentation directly from the audience?
So far, we don't have any questions, so all participants are encouraged to ask their questions if they have any, but they can also keep them, of course, for later for the panel discussion.
Okay. Then let's keep the questions for the panel discussion. And let's continue with our next speaker, Dr. Dirk Schwede. He's the team lead chair of heating and ventilation team, system integration and sustainable buildings at the University of Stuttgart. And his research is focused on sustainable development in Asian context and climate through architecture and engineering measures in the built environment, as well as on adapted sustainable building approaches for developing and emerging countries. Dirk, we're very happy that you're part of the panel. The floor is all yours.
Yes, thank you, Sonia, for the introduction. Can you switch the slides for me? Thank you. I would like to introduce a project we are working on, funded by the German Ministry of Education and Research. It's in the Client 2 program on sustainable development. And we are working on climate-adapted material research for the social-economic context in Vietnam, and we address this topic from different directions. And one of these directions is that we look from the technical point of view on the embedded carbon and also other life cycle impacts of materials. Can you turn the slides? Thank you. You can see here that the context first in Vietnam a few years ago, there was a new energy efficiency code introduced by the Ministry of Construction, and at the same time the Ministry of Construction and also the building industry wanted to advance the building materials and want to change from burnt bricks to unburned bricks, so to alternative, more sustainable building materials. And within this change, a lot of problems occurred. Partly it was building physical problems like cracks in the walls, like different behavior in the hot and humid climate, also other behavior of, let's say, known construction materials from which we have been a lot of experience in Europe, for example, but they just behave differently due to a different climate, but also due to other resources, like the sand is different and other raw materials are different. Our project is working together with a large consortium from Germany, which you can see here, and also with our colleagues from Vietnam, 2 universities, and also the Vietnamese Institute for Building Materials, which is a research institute directly under the Ministry of Construction. Please go to the next slide. The aim is now to research on materials. First is to characterize materials, to know and to find out what kind of performance these materials have in terms of heat conductivity, for example, but also in the hydrothermic behavior. And our part of the University of Stuttgart is also to do a life cycle assessment of the traditional material, the burnt bricks, but also the unburnt bricks. There is a lot of interest by a lot of stakeholders, which you can see here in the bottom line. We have been talking to IFC, to UNDP, and of course also to the Ministry of Construction about this topic, because many players are interested in not only the building performance, but also where the materials are coming from and what is the material resource consumption for the production of materials. Please, the next slide. You can see here the background in Vietnam. The construction market is booming, it's increasing. There's an average increase of 7% annually of the construction sector. And this is of course driven once by the population growth in the country, by the moving into the city, and as a third trend, of course, also that people get richer, that they have new demands, and with that also the construction practice is changing. Please change the slide. The topic we are addressing in our work package is that the clay bricks, the traditional burnt clay bricks, are to be replaced by unburnt bricks. Here at the moment, 87% of the bricks are fired clay bricks, and they are produced in more than 10,000 traditional clay brick kilns. So it's a, let's say, pre-industrial way of production with a lot of resource consumption, a lot of energy consumption, but with also impact on air quality and also land degradation, land use. They basically use the clay from the agricultural land, and by that they destroy the agricultural land. Please turn the slides. Our aim is to produce some kind like a material label, which could be similar to what we know as environmental product declaration in Europe, but also these material labels should include the basic characteristics like the thermal properties, the hydrothermal properties, so that the designers get the opportunity and get the means to choose a material based on the performance. And then also we would like to put into the label the embedded carbon and other life cycle impacts, also some statement on how the materials can be recycled. And this is our work at the moment to support the designers to build better buildings, but also to have a basis for building certification. What we have recognized now that some of the producers we are working with are also very interested in our results to improve the processes of production. Please turn to the slide. The process we are stepping through, and this is, let's say, the tedious work of our research at the moment, that we model the production process first of different building materials. Then we identify producers of building materials and do interviews by, let's say, surveys, questionnaires, but also online interviews, asking detailed questions. Then we use a modeling software for a life cycle assessment, where we model the process of material production very detailed with all the inputs and outputs. And then there is a quantification of environmental impacts, like the embedded carbon, but not only the embedded carbon, but also other environmental impacts. Please turn the slide. Yeah, here you can see the process of a fired clay brick, and you see that there are different steps which we model and put into our calculation. This is the extraction of raw material, transport, and then the different production steps, like also burning, firing, drying, cooling, and so on, so that we understand what is used, how much carbon is included in the materials, and what other impacts are produced by the materials. So we are looking at the traditional fired clay bricks, but also at other alternatives materials like the autoclaved aerated concrete, AAC bricks, which was mentioned by Peter before, which is also one of the alternative materials where the government and also other organizations put a lot of hope as a replacement for the fired clay bricks. Then there's folk concrete and also concrete bricks, but in our project we not only investigate these materials, but also work with our partners in Vietnam with these procedure, with a method of assessment, so that more and more materials can be addressed in this way. Please turn the page. Yeah, this is just an example for the questionnaire here. It's of course all in English and then in Vietnamese. We are relying on the help of our partners. Please turn the page. Here you can see the modeling in the LCA software, where the different process steps are shown, and then the flows of energy, flows of materials, of resources are modeled, so that we can really understand how the materials are produced. And we have then this model on the screen to calculate the environmental impact. Please turn the page. The output is something like this. We get an understanding not only about the environmental impact in terms of global warming potential, ozone depletion potential, and other dimensions, which we are also using when we do the calculations for environmental product declarations in Europe, which we are also using, for example, for building certification studies. But we also, of course, understand how big is the impact of the entire process, but also of the different process steps, so that we can identify in which step the process could be improved, and it can be communicated to the producers, of course, so that there also can be an optimization of the production of materials. This is at the moment ongoing work, which we are doing with our partners in Vietnam. We have seen that the topic has arrived in Vietnam, and many people know about life cycle assessment and so on. So that the basis is very good to do this work. What is currently missing is the detailed data, and our project has the objective to set the basis, so that we have localized, locally valid and locally appropriate data on some of the materials, and we hope that we can produce more and more of these data, so that the embedded carbon and the other environmental impacts can be considered in the design, and also in policy making and certification, labeling, and so on. Thank you. I think, can you turn the slide? And yes, I think I'm at the end. This was our case study from Vietnam. As I said, work in progress. We have a few more years to work on this topic, and we are looking forward to deliver our results, so that it's useful to make a contribution to the development. Thank you.
Thank you very much, Dirk, for providing insights from your project from Vietnam. I feel it can almost be used as a blueprint for other countries with fast-growing construction sectors. So good insights there. Julia, do we have any questions from the audience to Dirk directly?
Yes, we do. We actually also have one to Peter, which I will postpone to later, because I think that other panelists might also be able to chip in there. But there's a question from Ditram to Dirk. How do you see the potential for wooden or plant material as building materials in Asia as a way for sequestering carbon during the lifetime of buildings and transitioning to low carbon building materials?
We are looking into this in another project. We are doing our Rethink project, where we look at bio-based materials as one part of the project. I think wooden materials always there we have the problem, where does a wood come from, and is this sustainable? In general, it's good. In our Rethink project, we are also looking at materials, bio-based materials from areas which are not in competition with agricultural applications, and also which are not putting the forest in danger. Like we are talking about tufa boards, which are basically some kind of grass, of schilf in German, where we can make very rigid and very durable boards from. There we see some opportunity. At the same time, we have to be careful that wood in this climate is, of course, exposed to a lot of humidity and so on. So I think if this is aligned with material research and it's carefully done, there is a lot of opportunity for that, not only for wood, but also for other bio-based materials, I believe.
Thank you, Dirk. I see that our panelist Ari has raised his hand. Ari, do you have a question to Dirk directly? If so, you're still muted.
Yes, sorry. Yes, now should be online. Yes, yes. From my point of view, I'm interested in the system that you are using for the walls, outer walls, or the other envelope when it comes to the insulation. So you can think, at least from the Nordic countries, that it's useful also to have a insulation in the envelope in order to keep cool inside and hot outside in tropic countries. Have you considered what kind of physics is preferred there from the point of view of the construction materials?
Yes, of course. This is one part of the project that the colleagues of Fraunhofer Institute for Building Physics and also of Vietnamese Institute for Building Material, they are measuring the heat conductivity of materials. And of course, we don't need so much insulation as you need in Finland or we need in Germany in this climate, but a certain amount of insulation is necessary. Not only in the walls, but also in the roof slab, of course. And there also the aerated concrete would help and would be a good material. What we have also seen, because we also do a lot of measurement in apartments in Vietnam, is that also the weight and the thermal capacity of the material plays a role. Because sometimes the buildings heat up during the day, and then the air conditioning is used and is not able to cool down because there's so much heat stored in the heavy materials. And also, so these effects, which we don't really consider when we design our buildings in Germany in this way, must be considered. So there is some building physics which we have to think new, especially when the buildings which are built in Vietnam and in these tropical climates are now conditioned. Not all of these buildings are conditioned at the moment, but in future we can assume that the people will condition the building, and then the building physics will change. And we have to consider this with the selection of materials, that we have lighter materials which don't store too much heat and so on. We will work this out in our project and, let's say, write some kind of guideline based on our results on that as well.
Okay, thanks. Very good.
Thank you, Dirk. I'm sure there will be many more questions in our panel discussion, but I want to move on now to our next panelist, to Marina Fecke. She is a junior researcher at the Wuppertal Institute for Climate, Environment and Energy. And the Wuppertal Institute sees itself as a leading international think tank for sustainability research. And Marina's research is focused on developing circular approaches within industry with an emphasis on resource conservation. Marina, the floor is yours.
Yes, thank you very much for the introduction and the opportunity to give you a short insight into our analysis within the project CEVI, which stands for, I will explain you later, but looking at possible measures for substituting raw materials to reduce the carbon footprint on the one hand and to increase the resource efficiency in the buildings on the other hand. I try to put on the next slide, but I have the feeling that it's not working. Could you do that for me? Yeah, perfect, thank you. We already had a quite interesting discussion about raw materials and renewable ones. So the project CEVI stands for Circular Economy as an innovation driver for a climate neutral and resource efficient economy. And it's a project funded by the Federal Ministry for the Environment, Nature Conservation and Nuclear Safety, which we, the Wuppertal Institute, are conducting together with the 2 Degrees Foundation and the Worldwide Fund for Nature in Germany. So we aim to bring together actors from a wide range of backgrounds to hopefully initiate a change in today's economic system in the building sector. Could you turn on the next page, please? Yeah, thank you. So why are we looking specifically at the building sector? Well, the construction sector is one of the most resource-intensive industries in Germany, with around 4 million tons of CO2 equivalent in 2018. So the sector is also responsible for 55% of the total waste generated in Germany, equivalent to 229 million tons of construction and demolition waste, which is currently neither recycled nor reused in a high-quality manner. So in addition to the high emissions caused by the production of building materials, buildings are responsible for 36% of energy consumption in Germany during their use phase, so electricity and so on. Furthermore, the construction of buildings is associated with high land consumption. For example, in Germany, the average living space per person is increasing. In 1991, we could see a living space per person which was around 35 square meters and was already up to 47 square meters in 2019. So next page, please. So within our project CEVI, we want to start exactly at this point and bring together stakeholders from business, science, and politics in interactive workshops and model pilot projects in order to address important CO2 reduction potentials, transform material use, initiate changes, and develop and communicate entrepreneurial solutions. So that's the idea about the project. But we're still starting as well. So next page, please. In a first step, we conducted a pre-study on the opportunities and risks of the building sector to achieve climate neutrality and resource efficiency from the science field. Next page, please. So we looked specifically at these 4 CE approaches and matched different measures from practice to them. So we had the closing of material cycles, increasing product and material efficiency, life extension and efficient use, and substitution of resources and materials. Today, I want to focus on the possibilities of substituting resources and materials in order to reduce or avoid negative impacts. So that's the most important thing in this field. On the next page, you can see the result of our analysis. We've identified 6 fields of action in general, which offer a good contribution to climate neutrality and resource efficiency in the building sector. So we had the lightweight construction in the building sector, modular construction, alternative living and office concepts, circular building, material trade, reuse, and of course, the renewable resources. In the context of substituting resources and materials, we identified the use of renewable resources as specifically beneficial regarding the potential to achieve a resource efficient and climate neutral building sector. And as you can see on the next page, this measure starts at the beginning of the value chain of a building and therefore offers perfect opportunities to influence not just one stage of the value chain, but the overall stages. So within the project, we try to find fields of action on every stage of the value chain. But yeah, the renewable resources can start in the beginning and therefore influence all of the stages. So on the next page, we go deeper to the renewable resources. So in total, the production of building materials causes 250 million tons of CO2 emissions per year in Europe. And this amount could be reduced by substituting energy-intensive materials such as concrete or steel, for example, as we heard before. So in this field of action, we explore together with the participating stakeholders the wide variety of applications, for example, the possibility of a wooden construction, as well as the use of other renewable raw materials as building materials, just like cardboard, straw, or hemp, or as insulation materials that was discussed before, for example, jute or flax, which is also really important. And for this purpose, we have designed questions as idea stimuli, which can be explored in the following workshop phase, and that would be interesting to look on. For example, if a cooperation with farmers or foresters could be feasible, or how this is important, or what kind of characteristics must the renewable resource bring in comparison to the conventional materials. So on the next page, you see the evaluation of these measures. So in our analysis, we found that the use of renewable resources enables, in general, a better CO2 balance than, for example, mineral building materials. This is due, among other things, of course, to energy savings in the manufacturing and preparation processes, because the wood you just need to process and you don't have to manufacture it at great expense, just like concrete or steel. And in addition, improved logistics for regional raw materials or woods can lead to CO2 emission savings. But there's still a need for research about the behavior of natural materials regarding the fire protection and smoldering behavior, sound insulation, thermal insulation, and moisture protection. Particularly in terms of fire protection behavior, natural insulation materials are, contrary to expectations, usually more advantageous than conventional insulation materials, for example, styrofoam. So these contributions to climate neutrality are offset by some risks. However, the increased use of the resources can cause a loss of biodiversity through deforestation or monocultures, which reduces, on the other hand, the CO2 absorption. And importing the wood from abroad, as well as intensive farming, can also generate further emissions. So you have to bear that in mind as well. At the same time, this field of action shows a considerable potential for resource efficiency and could enable an increase in recycling by replacing harmful and finite raw materials with renewable ones. At this point, however, the recyclability of the raw material must be taken into account, which is why, for example, no impregnating agents may be used for wood. And furthermore, in the case of woods, there's the risk of insufficient raw material availability, as we already saw in the last couple of weeks and months. And in the case of renewable raw materials, there's the risk of land competition with agriculture for food. But overall, renewable raw materials offer a wide range of applications in building construction and, as explained, a high positive contribution to the building sector. And also further regulatory support is expected in the future, at least in Germany. So we see really a high positive contribution to transform the building sector into a more sustainable one. So yeah, thank you. And on the next page, you see my contact details. So if you have further questions about our analysis, please contact me, or you can also see more information about the project on our project website, which is also in English available. And thank you for your attention.
Thank you, Marina, for your presentation. Julia, do we have any direct questions to Marina?
Not for the moment.
Okay, then everyone can save their questions for the panel discussion. And we continue with our last panelist, Ari Ilomäki. He's the Senior Advisor to the Ministry of the Environment, Finland. And Ari has been overseeing the review of the Finnish building regulation and contributed to the development of the new regulation on the digitization of public procurement standards for buildings in Finland. And he will talk about this now. So thank you very much for being here, Ari. The floor is yours.
Thank you. Thank you. Can you hear me and see me now?
Yes.
Oh, thank you. Okay. Yes, I'm Ari Ilmäki, working for the Ministry of Environment in Finland as a senior advisor. But before that, I was working for the, I think, 24 years in the different organizations, associations in the construction industry. So I've been working in the Ministry of Environment since last November, so half a year now. And I have to also say here that when it comes to the sustainability issues, I've been the chair of CEN TC50, Sustainability Construction Works at CEN, for 15 years before that. So starting on 2004 or 5 and ending now in last November. So have an experience on this sustainability issues. And when it comes to my role in the Ministry of Environment, yes, I'm involved in when it comes to the developing regulations for the low carbon buildings, and especially for the carbon footprint or life cycle characteristics. I'm involved in there, but also I'm also the Finnish representative in the Commission group called CPR Acquis group, which is developing the rules for the further development of the CPR, so construction product declarations. But now we can go, I think, for the very good. Yeah, okay, now it works. So when it comes to what we are doing in Finland, so we are now working with a framework for the low carbon buildings regulations. And what does it mean? It means that we are going to have a new law or revised law for buildings, which includes also chapters for the low carbon buildings, includes also chapters for national carbon database, which is included or is related to the low carbon buildings. And we are also having chapters for the life cycle characteristics of buildings when it comes to the other characteristics that we have to take care of in the future, which are relating also to when you are calculating especially carbon footprint of buildings. And then we have regulations, which is a little bit lower in the sense of the law, because those are defined by the Ministry of the Environment. So we will have climate declaration of buildings, and we will have also, okay, covered by the whole representatives of the Finnish Parliament, which is covering the limit values for carbon footprint of new buildings. So we are following here the same route that has been already used for the energy performance of buildings and regulations for those. So there's nothing new here. This is only equivalent, how do you say it? Next step from the energy performance regulations, then we are going to the carbon regulations. but they are going to be there together. So we don't have only carbon regulations. We will also have energy regulations and carbon regulations in the future in Finland. And when it comes to where you have the information for the carbon regulations or carbon calculations, that's where we have to have also so-called material declaration of buildings, which is also regulations under our ministry. And maybe it's worth saying here that it doesn't cover all buildings. First of all, when it comes to the climate declaration of buildings, yeah, that covers almost all buildings. But when it comes to the limit values for carbon footprint of new buildings, it covers only, like it says, new buildings, but not, it doesn't cover single family houses. So, but when it comes to the material declaration of buildings, it covers new buildings and major renovation projects. And that is coming as a mandatory declaration also for the, or information also the climate declaration of buildings, meaning also major renovation of projects and single family houses. They also have to have declaration prepared, so we know what are the emissions, what is the carbon footprint, and what is carbon handprint, where we are coming in a moment. So we know that in the future also how it involves in Finland. Okay. No. Okay, now, so we have the main content of the requirements for low carbon buildings. So we have the climate declaration. So you have to calculate carbon footprint. And that's according to the EN standards. So it has been a little bit simplified in the regulation, but you can use also, so in order to simplify it, you have to use National Carbon Database, or you can use also EPDs when it comes to the global warming potential information from the EN 15804 plus A2 version. So that's what you will have as a input information in our climate declaration calculations. And what does it mean when we talk about carbon footprint? It means that it's global warming potential. I think we know what that does mean. It means results within the system boundary. So all emissions and removals, meaning net loads. But then we have a carbon handprint, which is more or less, well, I think it's, yeah, more what we have in the Model D in the EN 15804. But it depends how you sense it, how you realize it or understand it. So it means global warming potential results outside the system boundary, which are resulting from the building life cycle, meaning potential avoided emissions and removals, meaning net benefits. But I will come back to that in the next slide. So then we coming to the picture where we can show how this relates to the limit values. So of the building, because of the limit values from the legal point of view, we have been made this separation between carbon footprint of building and carbon footprint of building site works. Because in where we are working now, in our sector in Ministry of the Environment, we are controlling only the left side of the picture. So carbon footprint of the building. It means everything which is below, which is up in the ground, above the ground, meaning structural assembly systems, and also other assembly systems, or main assembly systems for, of course, for heating, cooling, ventilation, and lighting, which can also be located below the ground. So this is because of the, in order to be in line with the energy performance calculations and regulations also. So from those, we are getting so-called limit values for the new buildings. And then we are having carbon footprint of a building site works. That means site works which are below the ground, except those mentioned on the left-hand side in the picture, and also assembled systems in substructures, also except those which are mentioned there on the left-hand side of the picture. So the idea is there that in our system in Finland, in the regulation system, those who are regulating the building cannot regulate the building site, because the building site is normally autonomy of communities, different communities in Finland. So that's why those communities can regulate their own areas, and that's why also we are now only give them the information on basis that they can regulate their areas when it comes to the carbon footprint of building site. So we hope that this brings into conclusion that when those communities are regulating their sites where to build new buildings or to renovate lots or major renovations, they can also take into account this, what we are having now as an idea. And I think we have a common understanding now with the communities in Finland that this is going on. But this is very important from point of view that when it comes to the area you are building your apartment or apartment house or single family house or whatever you are building there can be ground area that you have to stabilize or you have to use piles. Then it's not mentioned, it's not meant for the building regulations to regulate how you can use your stabilization or piles or underground structures. So then it's in the hands of the communities. And this is I think the difficult part of our work here when it comes to the carbon footprint of the whole building. But anyway, we have trying to solve this in this way. And now the picture which shows, for those who don't know, how the setting in the rules in the standards are going in EN 54, EN 5978, in Sense standards and 350. So we are assessing the building life cycle when it comes to the carbon footprint of building life cycle. Everything is starting from the product stage. Then we are coming to the construction stage and then use stage. But in Finland, we have been simplified our approach in a way that we are only taking account those impacts that are significant for the results, meaning that when it comes to the replacement, of course, that's very well significant. But we also, I think it's in the next slide, but anyway, here I can say it also that we have agreed, according to EU levels approach, we have agreed that the assessment period for the life cycle of the building is 50 years. That means that the reason for that in Finland is that the normal, well, how do you call it, major renovation or deep renovation is usually done, at least for the apartment buildings, after 50 years. And it's difficult to assess what kind of system we have in place at that time. That's why we're using 50 years as an assessment period. And then we are allowing or using only replacements as a use case from the construction products to be used as information in our assessment. And that means also that when it comes to the replacement, it doesn't mean also actual replacement. It means also when you are having, let's say, bitumen like covering somewhere that you have to, in a way, replace, but the normal practice is do it just to have a new bitumen above of that bitumen layer, so you can do it in that way. So that is accounted inside replacement. So that's from the products part, so the embodied parts. And then we have an operational part, which is operational energy use. And that is, of course, energy use of the building for heating, cooling, ventilation, lighting, and ventilation, of course. And that is coming from the Energy Performance Buildings Directive. So that is included in our system. And then we are going to the end of life stage. And as agreed with Commission, we have to include also end of life stage when it comes to any assessment of life cycle within the building. So we are demolition or deconstruction, transport, waste processing, meaning waste processing for the reuse also, and disposal. That's the certain boundary of the life cycle. And I have to say here that it might be some, and it is a little bit different from the other products maybe, but since we have EN standards and since we have also ISO standards for this, we have been using it. So, which is relating also to the fact that when it comes to the circularity issues, like when you are using or reusing components which are coming from the other life cycle, or you are having secondary materials coming from the other life cycle, then those materials and products are coming into this system without any burdens of the previous life cycle. So everything that you are accounting here is included in this system.
Ari,
So
may I kindly ask you to conclude your presentation shortly,
Yes,
so we
yes.
have enough time for the panel discussion. Thanks so
Yes,
much.
yes. I have only one slide, I think, left after this. So this one. So then we have this potential carbon footprint of building life cycle. And this is like in EFIT 4, this is the model D. And maybe you all know where the model D is coming from. So those are all the benefits and also minus loads that you can have beyond life cycle of the system boundary. And then, but in here, in Finnish system, we have been also added in this model D, and we call it in a global warming potential, we call it carbon handprint. So we have been adding also what kind of biogenic carbon storage you can have in your product over the 100 life cycle or 100 years of the use, and also from same thing from the technical carbon storage, and also carbonation of the cementitious products in the next life cycle. And those are according to the EN 15978, and especially when it comes to storage effect, they are coming from the EN ISO 14067 to the carbon footprint of products standard. I think this was my last slide.
Thank you very much, Ari.
Yes, thank you. So we can continue the discussion if needed in panel.
Yes, exactly. Thank you, and thank you all the other speakers as well for sharing your knowledge. I feel I've learned a lot during the last hour, starting from how the building sector can be integrated into NDCs, how the fast-growing construction sector in Vietnam is becoming more sustainable, what alternative building materials exist, especially the advantages and disadvantages of wood, and how all these aspects can be combined in regulation. So now I want to start the panel discussion. So I kindly ask all panelists to switch on their videos, please. And I also want to encourage the audience to ask questions. You can either type them into the Q&A box, or you can simply raise your hand, and then my colleague Julia will unmute you so you can ask your question live. And also, of course, panelists, if you have questions about other presentations, you can also ask them. I wanted to start with the first question, reverting back to Peter's presentation. You've talked a lot about which building actions can be integrated into NDCs, but we know that only a very small number of countries actually mention embodied carbon. And I wanted to understand a bit better why you think this is.
Thanks, Sonia. I think that there's a lot of reasons why. I think the first one is awareness of how to regulate and how to what sort of actions will be feasibly implementable. I think there's also the other question in there about how many regulations deal with embodied carbon in the world. It also helps to answer this question of yours. So most countries don't have even regulation that covers the operational energy of their buildings. Only about 73 countries, or less than 40% of countries, regulate operational energy, and around about 22 countries have got regulations for embedded carbon. Most of those are in Europe. But the key markets which are growing in terms of new construction and really driving that emissions growth are in Asia Pacific at the moment. And there are no regulations that really cover embedded carbon in those markets, and particularly not in housing, which is where most of the growth is. And so it's kind of an urgency in engaging countries with rapidly growing markets to deal with this issue. And I think part of there's a range of connected issues here. One of them is that there's a lack of data. When we work in Southeast Asia, when we started working in India, even 6 years ago, there wasn't a really strong understanding of the dynamics of the industry, the existing building stock, value chains, the embedded emissions in material manufacturing, and so on. So there's quite a lot of data gaps. And I think that's part of the reason why it's perceived perhaps to be not practical or risky to make a commitment to regulating embedded carbon. So dealing with that data gap is a really important thing. And I think the other thing that I was sort of a question I wanted to ask the rest of the panel as well, that it relates to your question, is just general capacity in the building sector. If you think about who's doing the building, who's doing the procuring, it's mainly small to medium sized companies, a lot of very low margin work. And so the perceived risk of changing technologies or changing materials or construction practices is quite high. And so there's a need to look at that whole capacity building question. And the final thing is just in construction practices themselves and where the low-hanging fruit is. So I think we've heard some really great ideas and some fabulous initiatives around alternative materials or dealing with materials in the mass market. But there's also a lot to do with just reducing waste of materials and more efficient construction practices. There's a lot of opportunity in that area too. But I think the last point I'd make on this is a lot of these are issues of industry reform, which take a long time. And so there needs to be some sort of concerted action in these rapidly growing markets where there's a stepwise approach, or we would call it a roadmap or a strategy, or development of policy reform plans that build these components together. So yeah, that's why I think there's hesitancy, particularly in those fast growing markets. And I'd really like to know from the other panelists too about the capacity, the assumptions around capacity, and whether or not any of the initiatives are dealing with capacity building as well. I hope I answered your question, Sonia.
Yes, thanks. And I know you asked the question to the other panelists, so if you want to jump in and answer this, just go ahead.
Jarek's got his hand up there.
Yes, I wanted to ask a question in the same direction. So my feeling is that a lot of people we are talking with in the countries I'm working in China, in Vietnam, and also in Cambodia, that there is a lot of understanding of these life cycle assessment topic of embedded carbon and so on. But that, let's say, as you say, the data is not there, and also many other stakeholders, they are reluctant to provide the data. They fear that they have to disclose their production. They feel also criticized for what they do, and it's too much change in practice. And when we look at Europe, at Germany, and also what Ari presented in Finland, we are in a very, let's say, fortunate situation. We have all these data now, we have the databases, we have the tools, we have, and so on. And the question I would have is, how do we, let's say, bring these concepts to the countries where they are most needed? And my hope was that there are a lot of roadmaps, initiatives at the moment, not only the one of the Global Alliance, but also others. And my hope was that the first steps in this roadmap would be how to develop this data, how to do this very basic research, and to support the governments to lay the basis for, let's say, more sophisticated systems in this regard, because it is necessary, but it's very complex if we do it in the way we do it in Europe. We either have to find a way to do it
Yeah, definitely very valid point to find the right balance there. Ari, you wanted to jump right in, right? You are still muted, Ari. You are muted.
Okay, now, so from my point of view, I think it's important to understand that. So we have a global assessment rules how to calculate, for example, carbon footprint of buildings. So in order to have the so-called some kind of evidence to have this carbon footprint to be calculated and reliance on that, I think we need to use those standards. So it means that when it comes to the consultants who are going there in Southeast Asia or wherever, maybe there is a high demand for these kind of assessment rules, but at the same time, I think it's also needed in Africa and maybe East Europe and maybe outside south border of Russia, so the Asia part. So I think it's important the whole global economy and global community is taking part of this. So because we have all those rules how to calculate it, they can be maybe simplified a little bit, but then those rules need to be respected. So I think that's the only way how we can have honest results or reliable results on those assessments, and then we can say what is good for that country, what is bad for this country from point of view of the environmental impacts and or carbon footprint. So I think it's very important to use the global rules, otherwise it's a mess. It's a mess that we are having different rules in different countries, and nobody believes what we are having on as a result. So that's my point here. But I think that, for example, GBPN is using the global standards, and also all other people who are working in those areas. So that's my point at this stage.
Yes.
Thank you.
Thank you, Ari. Julia, do we have any questions from the audience?
Yes, we do. And I think, Peter, you already picked up a bit on this. So it concerns embedded carbon in building codes. The question is, how critical is this for reaching zero carbon buildings in the future? If you may want to elaborate.
Yeah, well, I think I mentioned that it isn't prevalent in building codes. That's the short answer. But how critical is it for reaching zero carbon? I think, taking a life cycle approach is obviously critical. I think, as I mentioned before, there are things we can do now without the regulatory reform process around waste minimization and around design innovation as well. I think there's a number of countries which are looking at aspects of more industrialized construction processes and also digitization, construction 4.0, as ways of being able to reform industry practices while they sort out the regulatory reform processes. But I think, so I think it is critical because it establishes that minimum performance requirements and that ecosystem, which was really laid out nicely by Ari, but it does take time. And I think that if we're going to stay ahead of or we stay on track to meet the Paris targets, then we should be looking at some of these immediate actions and also aspects of innovation which are there. I would also just come back to the question of the data gaps as well, and I would really agree with Dirk on that's also something that we can do now. And again, to dovetail from Ari's point, that we have got quite a lot of international systems and so forth in place. So that could be another thing that we do while we reform the regulations. There are a lot of voluntary standards though as well. I suppose that's the other aspect, that we have got guidelines and rating schemes and so on that do address embodied carbon. And so we don't really have a lack of options, but we do need some strategy and some prioritization.
Okay, thank you for answering this. As you also know, next week's webinar will deal with recycling. So I wanted to pose the question to Marina, but also to all other panelists. How do you think recycling of building materials can be encouraged further from your point of view?
Well, that's a really interesting and good question. And I think many institutions and projects are working on that. So that's specifically also what we try to find out in our project, because we have we saw that there's the field of action of reusing and recycling different components or materials or resources that are now in buildings. So I think it's the first step would be, or which is really important, to improve the English word is missing, like when you put down a building. So this has to be selective. So you need to get back all the materials as clean as possible. So if you mix all the materials, the cement, the concrete or whatever, it's hard to recycle it. So that would be, in my point of view, the first step to really get back the materials from old buildings as clean as possible. And then you, of course, need the right techniques, technologies that are able to really recycle the materials so you can reuse them in a high quality manner.
Thank you very much. Is there anything else that our speakers would like to add? Yes, Ari?
Yes, from my point of view, it's very good of what Marina was saying. Just that, can you hear me?
Yes.
Yeah, we can hear you.
Okay, I just noticed that everything's freeze in my computer, but you can hear me. Okay. And anyway, I think it was very important that you can, well, have the rules in your system which are, well, forcing you as a deconstruction company to separate all the construction materials from each other, because otherwise it's not possible to reuse them in the future. And that's why we are in Finland, for instance, having a new, well, framework, well, new legislation under Waste Framework Directive. And we are having that as a new legislation, having even more building materials to be separated during demolition or during deconstruction in order to be reused in next life cycle. But of course, that is affecting only on those which are, well, recyclable and demolished now at this moment and in the near future. But I think we have to start now. We have to have this new thinking when it comes to the deconstruction already when it comes to new buildings So you have to be able to deconstruct all the buildings materials at the end of its life cycle, or when it's going to be replaced by the other building product. So that is important in order to have this to be feasible and workable system in the future. So thank you.
Okay, thank you, Ari. I think we have to start now as a very good closing comment. And with this, I really would like to thank all our speakers for sharing your knowledge with us, for taking the time, but also for all the listeners to join in. We hope you learned something new today, and we also hope that you will join us for the next session, which is next week, Tuesday at the same time, where we discuss how the most important building materials, steel and cement, can become less emission intensive, and also how we can encourage recycling practices more. We will upload this webinar to our homepage, the NDE website, and we will also share the presentations there. Yeah, we wish you a great day, and thank you very much for joining.
Thank you.
Take care.
Thanks, everybody. Bye-bye.
Thank you very much.
Goodbye.
It's very good seminar. Thank you. Bye.
Thank you all. Bye.